Welcome back everyone. In this video we will talk about Thomas algorithm or some prerequisite of Thomas algorithm. Then maybe in the next video we will talk about the algorithm itself, and then we will take up one example. So before going into the details of this algorithm, first let us understand the uh, type of matrix based on its elements, whether the elements are zero or non-zero. So first matrix is called dense matrix. Dense matrix means that number of non-zero elements are greater than number of zero elements. That means, let us say if this is the matrix 1 0 2 2 3 0 5 0 8. So in this matrix we have three zeros and six non-zeros. That means this matrix is dense matrix since the number of non-zero elements are greater than the number of zero elements. The second type of matrix based on the elements is called banded matrix. Or let before going into the banded matrix, let's talk about the second type of matrix, that is called sparse matrix. So in sparse matrix, number of non-zero elements is less than number of zero elements. So that means, let us say if this is the matrix 0 0 2 2 0 0, and if we have 5 0 8, in this matrix there are 5 zeros and non-zeros are 4. So this matrix is sparse matrix. Now there is one type of matrix that is called banded matrix, which is a sparse matrix. So banded matrix definition is that matrix contains non-zero elements only along main diagonal and parallel to main diagonal. So this means that suppose if this is my matrix, so here we have a non-zero element, 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 and this will go till the end, and here we will have a non-zero element. Similarly, here we have a non-zero element, 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 and then here we have a non-zero element. Here we have a non-zero element, here, 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 and then here. Similarly, we will have a non-zero element here, and here are zeros. So this is the type of matrix I am talking about. This is called banded matrix. Now there is one thing which there is one property of banded matrix, that is called bandwidth. Now bandwidth is defined as S is equal to A plus B minus 1, where A is defined as number of non-zero elements on the first row and number of non-zero rows in the first column. So if we talk about the bandwidth of this matrix, then it becomes S is equal to 3 plus 3 minus 1, and that is nothing but 5. Now Thomas algorithm is defined for this algorithm is defined for banded matrix with bandwidth of 3, and that type of matrix is called tridiagonal matrix. So Thomas algorithm is applicable for tridiagonal matrix, which means we will have a main diagonal with non-zero elements, and we will have two more diagonals adjacent to the main diagonal with non-zero elements. So essentially Thomas algorithm is defined for a matrix which has elements like D1, U1, L2, D2, U2, L3, D3, U3, and this will keep on going, and then we will have Dn, Un minus 1, and here we will have Ln. So for this kind of matrix, we will have the Thomas algorithm. So essentially with Thomas algorithm, what we are doing, we are trying to invert this matrix. Essentially we are finding the solution of Ax is equal to B or x is equal to A inverse B. This is what we are trying to find out with this Thomas algorithm. So the Thomas algorithm has the matrix form of, let us write down that matrix again very clearly. This is my D1, this is my L2, U1, D2, U2, 0, L3, D3, U3, and this will go Un minus 1, Dn, and this will go till Ln, and here we have 0 and here also we have zeros. So this is my matrix A. With this matrix A, I will have a vector x1, x2, x3 going up to xn, and on the right hand side we will have b1, b2, b3 going up to bn. So essentially we are trying to find out the solution of this matrix Ax is equal to B. So the idea behind Thomas algorithm is that we will define two vectors, one is alpha and beta vectors with size of n. Now let us talk about this. So we have the matrix system. So if we write down the first equation, now we are trying to write down that matrix system in the form of equation. So this is my matrix D1, U1, L2, D2, U2, L3, D3, U3 going Ln, Dn, Un minus 1. x1 x2 going up to xn, b1 b2 going up to bn. So that matrix system essentially means that we are trying to find out the solution of d1 x1 plus u1 x2 is equal to b1, l2 x1 plus d2 x2 plus u2 x3 is equal to b3, l3 x2 plus d3 x3 plus u3 x4 is equal to b3 going up to ln xn minus 1 plus dn xn is equal to bn. So this is my the, the the equation form of this matrix system is here. So we'll continue in the next video with the algorithm.